think a trend in my research is that I really enjoy studying kind of like big, complicated, messy systems. So the air is kind of like that. There's, thousands or tens of thousands of chemicals floating around at any given moment, at least in the outdoor environment. And like developing the tools to understand that mixture is super, super exciting.
Hello, and welcome to Engineering the Future, a show from the McKelvey School of Engineering at Washington University in St. Louis. I'm Sean Ballard, science writer, engineering enthusiast, and part-time podcast host. Today, I am here with Jenna Ditto, assistant professor in the Department of Energy, Environmental, and Chemical Engineering. Welcome, Jenna.
Hi, thanks so much.
It's great to have you here. So tell me a bit about how you got into environmental and chemical engineering. What drew you to this field?
Yeah, well, the environmental engineering aspect is a bit newer to me. Chemical engineering, I studied in undergrad. I got into it originally because I really liked chemistry in high school, and I really liked math in high school. And so originally, I think it was just me kind of thinking about a way to combine those two interests into something to study in undergrad. And so I picked chemical engineering sort of initially, ended up sticking with it, ended up kind of finding pockets of it that really resonated with me. Including sort of that environmental piece. So I think the more I went through my chemical engineering courses, the more I started to look for, like how can I relate this to the environment somehow? At the time, I didn't have an environmental engineering option. So I was like seeking out those environmental kind of opportunities within chemical engineering. And then in graduate school, I joined a department that was both chemical and environmental engineering. So that's sort of where I fully leaned in, I think, to the more environmental aspect, but it was something that was, I don't know, I think I was gravitating towards for a while. So
yeah, can you tell me more about those pockets of environmental engineering? Like, what were those questions that really were like drawing you in and attracting you to environmental engineering?
So I think when I was taking some of the like fundamental chemical engineering courses in undergrad, I think thinking about kind of the impact of kind of the world of chemistry on people sort of started to rope me in a little bit, and that kind of has like a very natural connection to the environment, thinking about the chemicals in the environment that we're exposed to all the time. At the time I was doing a little bit of undergraduate research thinking about water quality, but now I'm an air quality researcher, but both of those different types of media are prime I guess suspects for human exposure in different ways. So really thinking about like what chemicals are out there, what are we breathing, what are we drinking, what are we eating, was kind of where I got started from a chemical engineering lens. And then, as I said, I kind of leaned more into the environmental engineering, like coursework and research a little bit later.
Okay. Yeah, I love that. So I want to just like even push a little bit more, as I'm so curious. You've mentioned sort of research experiences and getting into these questions of, chemical exposures that humans have through, through the air, through the water, things like that. What were some of those like maybe formative research experiences that you had? Can you tell us more about that?
Sure, yeah. So the first time I did research, I actually wouldn't even necessarily call it research yet, but I was a study abroad intern when I was in Australia during my undergrad, and I was working in this totally not related to engineering lab where the folks in that group studied the biodiversity of cities, like coastal cities. So Sydney, Australia is on the coast. They have a lot of like great diversity along their coastlines in terms of species that live in the water. And so that's what their group was doing. So totally unrelated to like anything I've ever done before or after that. But during that time, I was basically like a helper in the lab and went out to the field with a couple of grad students who were in the group at the time. And basically like, helped them with their measurements, took notes and things like that. But I think kind of seeing them exist in that space and seeing them, thinking about research questions that they had, executing these field projects really was eye-opening. That was the first time I think I really saw like what it might mean to have a career in research.
Okay, so that kind of like early collaborative field work seems to sort of based on your later projects have really inspired an ongoing commitment to that kind of work for you. Is that the case? And can you tell us more about your field work kind of as it stands since then?
Yeah, I think studying air quality is really unique from that perspective. Like a lot of our measurements can happen in the lab. We can simulate what happens in real indoor or outdoor air, but like ultimately What we want to know is, are these things realistic? So like you have to go out into the field and make measurements with a bunch of other research groups also making their measurements. So it's neat because you get to work with people from like all over the place, right, who have all these different skills. So you bring one skill to the table, they bring other skills to the table, and you put them all together and you get a really cool sort of characterization of whatever is in the air because you put your heads together, basically. So that's, I think, a pretty unique thing about the air quality field in general, whether we're talking about like outdoor air sampling or indoor air sampling. They're both similar in that like we're better together. So we, you know, we each chip in what we can and can get some pretty cool science out of it. So like on the air quality in St. Louis front, what we'd really like to do is be able to collect air samples in a variety of different homes, sort of in the city, in different parts of the city, in homes that are, you know, close to major roadways, in homes that are close to like industrial activity or restaurants, or maybe in homes that are really isolated from all those things and beside a nice park, to try to understand a bit about how indoor air quality varies as a function of what's outside your home, and also like how it varies in terms of like characteristics of the home. So whether you have really good mechanical ventilation and filtration in your house, or whether you rely on opening your windows for cooling, or you know, anywhere in between. So I think what we have in mind for the future is really to try to like understand indoor air quality in St. Louis as it as a function of, you know, type of home and geographic location.
How does one take an air sample? Like, I'm imagining you with like a tube and you're like capturing some air. What does it look like?
There's a bunch of different ways you can do it. So the types of samplers vary wildly. The tube idea is not unlike often what we do.
Oh, wow, okay.
So like one way you can collect samples of like gases in the air is with these little tubes. They could be a variety of lengths, but they're generally packed with adsorbent material. So basically material that will stick to a variety of different types of gases that flow through the tube. So it's not just an empty tube, but it's a packed tube. And so you can use a little pump and basically pull air from outside or inside through that tube. The idea is that the gases then stick to that absorbent material, and then you can heat up that absorbent material and analyze what was in the air before. So that's one way. You can also collect atmospheric particles, so tiny suspended particles, basically in indoor or outdoor air, on filters, which is pretty much what it sounds like. They're like small circular filters that you can pull air through.
Oh, nice. Okay.
So there's a couple different ways. That's probably what we would do because it's cost effective, but it's also like easier to, you know, bring into a variety of different environments, and it's a little bit less disruptive to that environment to put, you know, something the size of a shoebox in there versus something much larger and louder and things. So
right, I can imagine asking, sort of envisioning you like coming to my house. We want to have a sample, you know, and like here's a shoebox versus like here's a vacuum pump.
It's all about like trying to be as respectful of, you know, the volunteers' time as possible and space. So that's also something we're working on, is just figuring out, you know, how do we collect these samples in a way that accomplishes our science goals, but that also is like realistic to build a bunch of these little samplers and sort of ask someone to house it on their kitchen table for a while. So, but generally what we're trying to do is figure out like which chemicals were in the environment we sampled in the first place. So like trying to identify them, and then also trying to quantify them. So figure out, okay, we know what was there. Can we determine how much was there? Because when we're thinking about human exposure, both of those matter. Like it's great if we know what's there, but ideally we want to know what and how much. If possible, if we can only know what, that's a really good start. And it's sometimes impossible to figure out how much. But ideally, if we're thinking about like risk assessments to, you know, or like like human exposure, and how much that might matter for our health, knowing both of those pieces is like the ultimate goal if possible. So like in general, that's what we're trying to do. And so we have a variety of different tools that we may use to like try to accomplish that.
Yeah, can you tell me maybe a specific example of, you know, you're looking at these chemicals, whether it's focused or broad. How does what you learn there from that analysis inform human health recommendations, or, you know, sort of once you've done this analysis, then what happens next? So I think maybe I can give an example about some indoor measurements that
we've been thinking about that are related to cooking.
A hot topic.
Everybody cooks, yes. Hot, literally. So like, for example, if you cook, meat or vegetables on a pan, we might, try to like sample those emissions and understand what is coming from the food we cook. So we may target, certain markers that we know, for example, to come from heated oil, or maybe some markers that we know come from like proteins in the meat breaking down. And then I guess ideally, these findings we can again learn about, like, okay, what is coming from this, for example, cooking emission scenario, how much of these chemicals are there, and then to your point about like what do we do with that information. A lot of the time in the indoor space, things tend to boil down to like ventilation a lot of the time, or like surface cleaning sometimes. So we can take, for example, our cooking measurements and say, okay, we measured compound XYZ, they're at these particular levels. We know the ventilation in the room was something, maybe it was on, maybe it wasn't. So a lot of the times it will boil down to like, okay, how can we get the ventilation in this space better? Like, was the range hood above your stove on? Is it really old? Does your filter need cleaning? Things like that. So I think those are like the sort of the types of recommendations we would hope to be able to make with our observations.
What is the biggest misconception people have about your work, and how would you set the record straight?
Well, I don't know if I would call it a misconception, but I think indoors, or often we treat like these indoor spaces as somewhere we would go to like shelter from outdoor air pollution. So like if there's a wildfire, you're better off going within a building if you can, and closing your doors and windows than you are standing outside in the smoke, for sure. But I think with that in mind, like the indoor environment is not always kind of chemical free, and so there's a lot of chemicals that come indoors from outdoors, and we also like produce a lot of chemical emissions in the indoor environment as well. So yeah, not that it's necessarily a misconception, but I think thinking about the indoor environment as like a unique and like worthwhile place to study, because not only do we get some of these exposures from outdoors while we're indoors, but also emissions from these unique indoor sources can sometimes be really high. So like thinking about cooking as an example, if you're cooking in a pan and you're standing right above your pan, you're inhaling whatever you're cooking within like really close proximity. And those exposures, like, you wouldn't necessarily get outside. So yeah, while it might not be like a real misconception per se, I guess I would just say that like indoor levels of chemicals are like important to think about. And it's not just that we're only exposed to outdoor air all the time. Like, there are these really unique and strong sources indoors that we should think about for exposure. Cooking being a really important one, cleaning being a really important one. If you like clean with bleach or whatever other cleaners, generally if you can smell them, that means that there's some chemical content there. So so thinking about not only what exists outside, but also like how do the levels of some of these unique chemicals that don't really exist so much outside impact us inside.
What are some other things that we could do, or people in general could do to help improve their air quality or mitigate some of those chemicals that we're getting?
Yeah.
Right. Like, is it an air purifier? Is it different kinds of products? What advice do you have for us regular folks who are maybe not aware of this as you are? And now you've really opened my eyes to a lot of stuff that I should maybe be thinking about, because I'm in my house a lot.
Yeah. I mean, we all are. Yeah. There's some statistics that people in my field love to cite, which is that we spend 90% of our time indoors. But that's your house, that's your office, that's your car, that's whatever public spaces you're in. But most of that 90% is in your house. So yeah, thinking about like what kinds of emissions are around you and how to control them, I think is really important. We talked about ventilation before. So like for cooking, I think that's a really major one, whether that's your range hood, whether that's opening a window when you're cooking. On the air purifier side, I think those are really great at controlling, depending on which type of purifier you get, they can be really great at controlling particles in indoor air. So when you think about, for example, particles from cooking, or even if you are living in an area where there's a wildfire smoke event, for example, outside, and you might get like a little bit of smoke inside your house, or like virus particles. So like during the COVID pandemic, certain air purifiers really, really help to remove those particles from the air, basically stick to a filter, and can lower the levels of particles in your space. So I think those are super helpful. And, you know, you can buy them, you can make them yourself. During the pandemic, there was some really great work and sort of advertising of these homemade air filters with like a box fan on top and some filters kind of around the side, so it's a little like cube that you can bring into your house, you can bring into a classroom, and so like tons of folks were making those, you know, from scratch themselves after a Home Depot trip, for example. So yeah, those are super helpful. I think doing this work has really like sharpened my focus on the ventilation piece, not so much changing like what I cook or what products I use, but more like, okay, if I'm cooking or cleaning, like let me try to reduce my exposure as much as possible.
I love that. I feel like that's accessible for us normies that do not know about engineering and indoor air quality. Crack a window. Anybody can.
Right.
I love that. Thank you so much.
Yeah.
All right. So I want to sort of shift back to a question I've been dying to ask all of our, people who we're having on this season. Of course, our theme is women in engineering, and thinking about energy, environmental, and chemical engineering specifically. This is an area where I feel like I, as a science writer, somebody who is talking with researchers a lot, I encounter more women in the field, and I love that. Full bias here, but I think it's great, and I wonder if you've observed that, and if so. What do you make of that? Is there something about this field that just does a better job of attracting and retaining women researchers?
Yeah, I mean, it's certainly something I have experienced. Well, I've experienced both sides of it. Like, I've experienced there being more women overall in environmental engineering compared to some of the other engineering fields. But I've also, I've experienced being in groups of environmental engineers where there have been, 50% women or more sometimes, where it's felt like a totally different atmosphere than, other times where I've been in a group of environmental engineers and I've been the only woman at the table. So like I've definitely experienced both multiple times. And yeah, I mean, I think it's certainly getting better. And I think, like folks like me going through the field now, I feel really lucky to have had these like other more senior women who have gone through and sort of paved the way, and are like really great role models for people like me, and then people like who are coming through their undergrad or grad programs now. So I think it's getting closer to being equal, and I think it's getting easier to look around and see people, like in my case, see like women who look like me, who have kind of gone through it, who have done the things that I want to do. So certainly very different going through this like now than it might have been a decade ago or 2 decades ago. So I think we're on the right track, but I think there's still a lot of work to be done.
Yeah.
But
yeah, what do you think that there's I don't want to say a reason for that. Like a lot of good work is being done to encourage more women to go into STEM broadly, and obviously very supportive of that, and glad to see it happening here at McKelvey. Do you think there's something about the field of environmental engineering that is appealing to women in a way that maybe other sort of subfields of engineering aren't?
One draw to environmental engineering for me specifically is like seeing how the work that I do, like the air quality that I study, or maybe the water quality that my colleagues study, directly impacts people, directly impacts like myself, my family, my friends, the neighbors across the street, like very directly. And I think, so that individual impact of what you do is really, really clear in environmental engineering. And I imagine, similar for something like biomedical engineering, if you're working on developing like a new like drug therapy or medical device, it's similarly like you can really like tangibly like feel and identify the impact that like your work will have on somebody. So I think, for me anyway, I think that's like a key draw to environmental engineering, is that I feel that the work that I'm doing like really has the potential to impact people's health in a positive way.
What are you most excited to be doing next?
So we've got a couple of projects that I'm really excited about in the lab right now. And both of them are pretty new to me. I think a trend in my research is that I really enjoy studying kind of like big, complicated, messy systems. So, so the air is kind of like that. There's, thousands or tens of thousands of chemicals floating around at any given moment, at least in the outdoor environment. And like developing the tools to understand that mixture is super, super exciting. And so we have a couple of projects that I think I'm really excited to get off the ground. One is looking at house dust. So dust is, a really fun, not so pretty mixture of things like pet dander and hair and skin flakes and maybe dirt from the outside and all sorts of things, right? Like it's really complicated, but it's everywhere. It's ubiquitous in all of our homes.
The amount of it that is skin that I've read about freaks me out. I'll be honest
It's a
with
lot.
you. It's a lot of skin.
Yeah.
And I don't know why that gives me this quick.
But it's a bunch of different things.
Yeah.
So it's a really complicated mixture, but it's so ubiquitous in all of our homes. And so we're just starting a project right now that's looking at the chemistry of dust. So there's been a lot of work thinking about what is in dust in the first place. So not only these like big components we just talked about, but like which individual chemicals from our day-to-day lives might stick to dust and sort of stay there over long periods of time. But we're thinking not only about what's there, but also how does it change? So how does it react with time, and how does that alter our exposures? I think a key reason to study dust is for children's exposures. So, if you have kids who are crawling around on a floor, they're closer to the dust. They may ingest a bunch of dust, or they're just closer to inhaling it. For adults, we inhale, resuspended dust off the floor if you sweep or something, but it's generally kids who have these like really large exposures potentially. So yeah, I think like understanding that really complicated mixture and how that complicated mixture is changing over time and what that means for our health is something we're just starting now.
Just for fun, in closing, Jenna, what are your top media recommendations right now? Any books, movies, TV, music that you've really been enjoying lately?
Yes. So I recently watched the show Ted Lasso. I don't know if you've seen it, but I've watched and like rewatched. I think because it's a couple years old now, but yeah, I really enjoyed it. I'm a sort of fair weather soccer fan. I enjoy it. I used to play, but it's not really something that's a major part of my life right now. But I think this like brought me back to really like trying to follow it a bit more again, and just I don't know. It's really funny. It's really sweet. It's a nice like show to get your mind off of, the day-to-day life. So yeah, that would be my recommendation if you're looking for a show.
That was amazing. Thank you so much, Jenna, for those amazing tips about what we should all be doing to maintain our indoor air quality at home. And I will look forward to hearing about what happens next with your work.
Yeah, thanks so much for having me.